Hello and welcome to All Things Abacus. Thank you so much for joining. My name is Miss Lynette. Welcome. Okay, so let me see if I can do a couple of things. Sorry. Okay, so we had a couple of questions about division. Hello. Hello, Sade. Hello, Sade. How's it going? Oh, sorry. I'm trying to. I'm so happy you joined. We need preschool abacus. Hello. Okay, great. Let me know if you have, well, what sort of questions you have. I actually have books. I have a membership as well. So I also have videos. And then I also have a membership. So you can actually come on my live and, we can have a conversation. Yep. It is also available on Amazon. Oh, Sade. Thank you. Like the singer, Sade. Thank you so much. I appreciate that. Um, we have your book too. Okay, so what page are you on? Let me know, and then we can talk about it. I also do have videos for all of my. I also have videos for all of my worksheets as well. So the way this book was sped up is because I wanted to be able to make sure that they did the like the singer. Yeah, nice, nice, nice. Oh, the reason why is we also have the abacus as well. So make sure you have the abacus and it lies flat. So when it lies flat, you want to be able to make sure that um it will go. Hello. Okay, hold on just a minute. Let me. Okay, so page 123. Okay, so page 123. Ah, yes. So this one is a lot about trying to get the kids to write as much as possible. So, hold on just a minute. Hello, Tammy.
Hey, it takes me a little longer than I thought it would.
That's all right. That's all right. Well, I just have a couple of questions on YouTube.
Oh, that's good because I gotta get my abacus.
Well, it's the preschool one. So this one here was trying to figure out who is bigger, right? So if this is one, and then this is zero. So what we're going to do is we're going to, whatever's bigger, you put into two dots. So this is bigger, so you put in two dots and you get them to circle it and then you can color it. And then whatever's smaller, you put it the one dot over here. Does that make sense? So when we're doing it, that's what it would look like. And then it's the same thing here. This one is 7. So I would write their number here and I would write the number here. And then here, this is 7. So put 7 here. And then there's 2 here. Are all of them supposed to be greater than? Yeah. Yeah. Yes. All of them are greater than. And then get them to practice the writing greater than. Yeah. Yeah. I didn't want to be too complicated. So they practice what greater than is. Yeah. 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 Thank you, Sade.
I think it was September. So does the
Let me know if you
motorcycle
have any more
carry the
questions.
truck and the truck goes
Yeah. Okay, yeah.
Cool.
I didn't want it to be too complicated. I didn't want the kids to be too complicated because I just want to make sure that they understood what the greater than sign, what's bigger and what's smaller. And so that's what I did. And then I think the next one over is everything is less than. And then they start seeing, so this one right here, oh, just so we use a cubes converter. Okay, good. So then here, this one right here is, this is the number. 7 is the number. They can choose any number they want to be less than 7 and greater than 7. So I try to get them to figure that out. Yeah. So that's what this is.
Bye.
Oh.
Bye.
All right.
Next time,
So
should I do the?
there we go. Let me know if you have any more questions. Can you explain how to count from? Okay, so here we go. So on the abacus, this is our ones place because we have our dot here. This dot tells me this is the ones place. So when we count 1, 2, 3, 4, 5, right? The top beat is always a value of 5. And then we have 6, 7, 8, 9, and then 10. That's what 10 is. Okay. So now we can count. We can keep counting 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. And then we can keep going. So if this is 30, right? 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay. That's how you do 40. And then let me go a little bit further. 41, 42, 43, 44, 45, 46, 47, 48, 49, and then 50, 0, 5. 5, 0. Okay? Yeah. I hope that's helpful. Pin spotlight for everybody. There we go. Okay. Yeah. How's it going, Sade? Does that make sense? I'm hoping that makes sense. Whew.
Can I show Alyssa something, Lynette?
Yep. Hold on. Alyssa, are you around?
She was.
Yes, I am.
Okay, good. There you go.
Okay, so you see, I've been working on this one, right?
Yeah.
Look what I got.
Oh, I want one of those.
I was so happy when it came in.
Cool. I like it.
The
I
13.
like it.
I honestly didn't think people would like the 13 column abacus. I thought it was too overwhelming.
No, it's great.
All right.
I'm
So
so happy.
I like the color.
Okay, back to what we're doing.
yeah. Well, no, it's Sade had some questions and she's on YouTube. So let me know if you have any questions. And then Alyssa, I was looking at the division.
What were your thoughts?
That's how regular school does it. The thoughts are I like how she broke it up. Okay, so the question was I like how she broke it up and it made a lot of sense. I just got to move my stuff now. I had the question too. Do you remember the question? Here, let me. Yeah.
I liked how, okay, so what I liked about the video is when you're doing, well, and even on the abacus, when you're doing it on the abacus, when you're doing it on the, she's visually showing you how, first of all, I like how she did the definitions.
Yes.
It's actually, the roles of each part in division, the divisor. The divisor is the one that's doing a lot of the work.
Yeah.
And then the quotient. I like how she get the
quotient.
The quotient, yeah. I'll never get that right.
Okay. You will.
But in that role, and also the dividend, but I love the definitions that she gave, and when she did it with those beads, actually seeing that the number 3 is there's going to be 3 groups of the quotient, and when you're doing quotient, there we go, quotient, you're able to, and I think we forget why that number is in there for the divisor. you're going to have three quotients, three
Well done.
groups of
Yes.
quotients. And you're just used to solving the problem. And
Yes.
then there's the number, and then that's it. And so I really like that. I thought she was pretty thorough on that.
Yeah, I liked that part. I didn't like the preloading everything because that's a very Eurocentric math.
Well, right, but you take what you have,
I
and
understand.
then you add to it.
Yes, and Abacus-Why it.
And Abacus-Why it, because see, even still right now, I could do the multiple, but when I'm doing a division, because see, she lost me when she was doing the beads. I couldn't keep track of what she was doing on the little board, and I still struggle when we're doing the Abacus-Why on the abacus when it's small, to keep track of what the dividend is, and then making sure that as you're using the divisor and you're multiplying and subtracting, that you're making that quotient smaller and keeping
Right.
track of where you're supposed to be.
Right.
That takes a lot of practice and starting small. She used a pretty big number, and
Yes.
when she used the 80, or is it
8073? That's what it is.
Okay,
8073. Uh-huh.
And then you're talking about with that dividend number, you see how many digits you have, and then you see, and then you subtract the divisor, but she used all four. There were four numbers after that. So how does that work?
What do you mean? I don't wait. What do you mean she used all four numbers?
I think the 8, because there's two of them that she did. She did one where you divided by 3.
Uh-huh.
And then she did another one. That one's is where it has only 1, 2, 3, 4, subtract 2. No, they'll have 3. There'll still be 3 digits in there. It was another one. She had another one where she just took 3 divided by another number. Do you remember that one?
Yeah, it was only a single digit one, so it'd be like,
yeah, it was only a single
3.
digit.
We could do it with this one, 087. I think we could do it with this one. I don't know. Okay, but doing this one was it not straightforward?
That one was very straight. That one was very straightforward. What she did with the 23, I liked how she set on the side. Basically, she did both numbers at the same time, where you do one digit at a time. You'll take your 2 and then you'll take your 3 with the 23 divided by.
Oh yeah,
73.
so that is actually a that's what public school does. Public schools, they do 23 times 1 is equal to 23, and then 23 times 2 is equal. So well, that's what I mean is that what she did is she front loaded everything, and so what would be the point of knowing your 23 times table when you can do distributive property?
Right.
Yeah. So this is what she did, and she wrote out her whole 69. Yeah, she wrote out the whole thing.
Yeah.
And I'm like, okay.
Yeah, that's fine.
Yeah. So,
but you do is you take the 2 and you say 2 times what goes into 8. That's what you do.
Yes, exactly. So what we do in Abacus is we do distributive property.
Yeah, because it's 8. Yeah, because it's 8 times 2 and then 8 times 3.
Yes. So
Okay.
here, let me get you a better question.
That's not a good one.
That's not a good one because
it doesn't leave any remainders, though. There's no remainders in that one.
No, it's a lot harder because there's a thing that I'm trying to explain, which is called what happens when you do too much. So if the quotient is too much, this would be the better question. Here, yeah. So that was the one struggle that I'm dealing with right now, is making sure that the questions makes sense. So we have 21, we have 4, 6, 2. Okay.
Can I do
So
this on my small one? Or
yes,
do I need to be okay? I could do it on the
yep, you
small
could
one.
do it on a small one.
Definitely small one.
Okay.
So yeah. So what we're doing right now is we're doing division. Before I continue, Sade, just to let you know, with the Abacus book, it towards the end, after they do the bigger than less than, we start going into adding and subtracting. So this is what adding and subtracting looks like. And I try to make it all with all the activities. Then when you're done with this, if you want more, I have more workbooks, but they should get ready. Your child should be ready to start doing adding the 5. And then this would be the curriculum. So you add the 5. Let's see. Where is it? So the idea, so after this would be adding the 5, and then after add the 5, you minus the 5. And then after minus the 5, there's the plus 10. And then there's the minus 10. And then there's the 2-step. And then I'm still working on a minus 2-step. Just so you know. Okay. So hopefully that made sense. We have the next book. Yeah. So when you're ready for this, yeah, that would be the next book after the preschool book. That was the idea that I had. And so then after they know how to plus the 5, then they go into minus the 5. That's what this is. Okay. Okay, great. Thank you, Sade. Yeah, but you can always ask me again. You can always ask me again. And there's like a whole curriculum. And so right now we're actually doing multiplication and division. Of course. Thank you, Sade. Okay, so we're back to division. What is our starting point? What do we know?
We want to know how many digits
Right.
we're working with.
So we have how many dividends?
3.
3. Yes, Sade. Any bundle deals on my tick? No. No, I don't have bundle deals. I have ebooks, but I don't have the ebooks ready on my website. But if you already have the plus 5, the bundles, the only bundle deals I have is like for adults. Yeah. I hope that's okay. Yeah, so we have 3 as our dividend, and then 2 is our divisor, right? So our location, our starting point, where are we going to put our quotient? Alyssa, where are we going to put our quotient?
At the very end on the
At the 1. No, we put it here. This is where it's going to start, quotient. Oh, I got to go over here. Your quotient will be here.
That's what that means?
Yeah, your
When
answer
you're
is going to be
So
here.
when you're subtracting, you start in the ones place. Okay, so I'm a little confused. So explain that again to me.
Our answer is going to be right here. What we're trying to do is figure out where will our answer be.
Okay.
That's what this is.
Okay.
Just like in multiplication, we want to know where our answer is.
That's a little bit, well. Oh, well, that's easier because you just add them all together.
Well, so the difference between multiplication and division is that we don't do a lot of dividing. We don't subtract naturally. We add naturally.
Right. Well, to finding out your place value, basically the reason why you're adding those in the multiplication is find out where your place value. So if it's if it's 32 times, well, like for this problem, 21 times 462, that would be 1, 2, 3, 4, 5. So you go 5 spaces over.
Yep.
Okay. So when you're dividing, you're
subtracting because that's the opposite of adding, right? Adding is subtracting. Dividing is the opposite of multiplying.
But you're still finding the place value as to where to start, right?
Yes, you're still finding where to put the answer.
Okay, and that answer is going to be in the
It's located in the ones place.
located in the ones place. This is the first time I've heard of this part. I'm just so used to, we subtract, and then I didn't know what what that purpose was. I
That's
got
fine.
it with I got that with the multiplication part, but I did not
Right.
know this.
Well, we don't do a lot of division either. Right.
No, but I'm
And
glad.
so,
Yeah, now
Right.
I know. But now I
yeah,
know.
yeah,
Because sometimes you just go through, you just do something just to do it without knowing what the meaning is. And I did, and it makes sense that you're doing the same thing for as you're doing for multiplication. You're finding
yes.
how
But,
big the problem is. But this
but
one,
yeah, exactly. I was just going to say, and that's the the difference is if you know how to add, you know how to subtract. If you know how to multiply, you'll know how to divide,
yeah, because
right?
that's what the 21 is doing to the 462 is dividing it into smaller groups.
Mm-hmm. Okay.
So, okay.
Okay. So now we know the quotient is here. The answer is going to be here. So the first thing we do in Abacus World, because this is now 2 digits, there's a 1 here and there's a 2 here, we got to figure out, we're going to use this 2 first.
Let me
We're
write
going
it
to
out.
use this 2 to figure out what's the closest thing. So we have 2 times what is equal to 4. Now remember, 4 is a single digit, so we got to make it a 0, 4. Do you remember that?
Yeah.
So I have to find. So just a little review in the multiplication book. And this was an epiphany when I made this connection. I was like, "Oh my God, this is why we do it." So we have to recognize that when it's a single digit, we have to make sure that there's a leading 0. That means that the
Yes.
0 holds the place of the tens. Because if you notice, we do it in money, we do it in time, we do it in date, we even do it when we talk about like hundreds. Notice when I do 10001, this 0 is the placeholder
Placeholder for the tens.
placeholder for the tens. That 0 needs to be recognized even here if there's only single digit. So when we're looking, we have 2 times what is equal to 4 or less.
2.
2. Oh, sorry. So I got to put in my dividend.
From
My dividend goes here, 6, and then 2. So my quotient is here. My dividend sits here.
Mm-hmm.
Does that make sense? My answer is right here. This is why I need to know the 0, 4, because now instead of putting my answer here, this is actually a 0. My first answer will be over here instead.
Right.
Why?
Because of the 0, 4.
Oh, because the 0 stands for the tens.
Yes. So we're looking at it like this. That's why it gets pushed over to here.
Oh. Oh.
It's a whole new light for Elisa.
Okay. Okay. No wonder why, because I would get confused because you start there and I thought it would be okay. That's good to know. So that's
Yeah.
the
So
tens place.
that's why you need to know every time it's a single digit, always make it a double digit.
Uh-huh.
Okay.
So 0, 4. And that means you subtract the 4.
Yeah. So
You
put the 2
subtract.
here. My answer is 2.
Oh, diddle, 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 diddle. Okay, yeah.
Okay. Don't forget that. You got to put the 2 here. And then we take away the 4. So we take away the 4. What happens? Well, because I did 2, right? It becomes 0. But now I got to multiply the 1. 2 times 1 is equal to 2.
Yeah.
2 is a single digit. Again, it should be 0, 2. So it pushes from here to here. So I have to take away 2 from here.
Right.
Okay.
Did that make sense, Alyssa?
Oh yeah, because you already subtracted the 4.
Yep, I already subtracted the 4. So now I'm at 2. So if I look at it, it's actually 21 times that by 2 is equal to 42. So what I did is I subtracted 42 from here. But what I did is I did distributive property. I take away the 2, and so I'm left with this.
Okay.
Okay. And then we do it again.
So then it would be 42 under the 46, right?
Yeah.
And that's
Yeah. It'd
what
be
we get.
42. Yep. It'd be 42 under the 46.
Oh, okay. Okay. Okay.
Okay. So we have 42. So then we're left with 42 again.
Okay.
So what times 2? And we go back. What times 2 is equal to 2 or less? Sorry. What times 2 is equal to 4 or less?
2. 2 times
Yeah.
2 equals
So put
4.
2 here. Remember, it's a 0, 4, right? So you put the 0, put the 2 here, and then take away the 4.
Okay, so that's the part that I'm getting lost with.
Oh, so if this is your quotient, if this is your dividend, you use your dividend to hold your place value.
Yeah.
So if
But
you
then you
hold your, so you want to go here, but because it is a single digit, it moves it over to here.
Okay, so I got the part where you do a 0, 2, but the 0, 2 is what you put on paper, but then you bring 2, so you go over. That's the part where I'm lost.
What's the 2? What's 0, 2? Oh, over here. Okay, yeah.
Yes.
So let's go back to something like this. So 21, 0, 4, 6, 2, right? So then what we did was, so what do? We do 2 times 1 is equal to what? We have 2, 0 times that by 2, 1 times 2. What does that look like? That's a 0, 4, and then this is a 2. It's a 2, right? So it gets us to 42. Okay, we understand that part, right?
Mm-hmm.
Just like what we do here. But when we break it up, this is still a 0, 2.
Okay.
Because it's a single digit. So this actually looks like this. So then if we line it up, 2 times 2 is equal to 0, 4. Here's my 0. 2 times 1 is equal to 0, 1. Or sorry, 0, 2. That's where that goes. So you bring down the 6 and you take away the 4. Take away the 2.
Wow. Okay.
Right? So we're following this. If you look 4, 0, 0, 4, 0, 0, 4, 0. This is becomes 0, and then we do 0, 2. This is 0, 2.
Oh. Okay. Okay. Wow. Okay.
It's a different way of thinking, which is different than what mainstream does. Mainstream does a front load because they're like, how many times does 21 go into 46? And I'm like, I don't know. I don't know how many times it goes. I just know how to multiply distributive property because we don't think in these terms.
So each time you're putting a 0 down, though, that's the leading 0 for the hundreds place, right?
It doesn't matter. It's a leading 0 to a single digit.
I like that better.
It's a single digit. Anytime the number is a single digit, don't worry about the place values because the place value is what's going to get more confusing. So anytime it's a single digit, you want to make it a double digit.
Okay. Okay, I'm going to ask you one small favor.
Go ahead.
Can we do this problem on a completely clean sheet of paper?
Yeah, of course. Yeah,
So-
of course, because I'm trying to
running out of room.
running it up. Yeah, trying to like write it nicely.
Right. Yes.
Okay, so 21.
And then bring the paper down a little bit.
Yeah. 4, 6, 2. And I also like to use different colors too. I hope this is okay.
I like different colors too because then it just.
So
Okay.
here we will imagine that there's the leading 0.
Okay.
Why? Because when we do 2 times what is equal to 4, this is where this is a single digit. So this becomes 0, 4.
Yep.
Okay, so let me rewrite it again because I messed up my alignment.
Yeah. So we do that on the side.
Yeah. So 0, 4, 6, 2.
Okay.
Okay. So what we did was we did 2 times 2 is equal to 0, 4. Okay. This becomes 0. And then what happens? Well, because we did this, now we got to do this. We got to bring this down.
Yep.
Bring that down to 6.
Yep. So now we go 1 times
2. You got to do 1 times 2 because this 2 is what, if you did it for one side, you got to do it for the other side. 1 times 2 is equal to 0, 2. Because because just like we do distributive property, right? Distributive property is 21 times 2. What do? We did 0, 4, 0, and then we did 0, 2, right? We did this first, and then we did this first. And that gives us 42.
Yeah, it does. Oh, yeah. Oh, wow. Okay, okay. Huh. Okay. Okay.
Okay.
Yeah.
So then
we haven't even done this on the Abacus yet, though. Okay. So
well, we have.
Right.
Because if you think about it, it's here we add 4, 6, 2.
Yep.
We add our 2, take away 4, take away 6, take away 2. Take away 2 is minus the 5 plus the 3.
3. Uh-huh. Okay. So then you do, and then there's the 4.
There's the 4. So we go again. What times 2, because we're here, what times 2 is equal to 4 or less?
2 times 2.
2 times 2. Remember, 0, 4.
4.
Okay. This becomes 0. And then this is where you bring down your 2.
Okay.
Right?
So
but we don't need
now
to do that because we have it here.
Yeah, you subtracted your 4, then added the 2, and now you subtract.
You
no,
see
you do
this.
the 2.
Yeah.
Okay, so then
1
2
times 2
is 2.
Yep. 0, 2.
So 2. So then your answer is 220.
No.
220.
No. Look at it. This is my 1s. This is my 10s. So my answer is 22.
Oh, what was I saying?
You said 100.
Oh, yeah. 22.
Yeah.
Oh, wow. Okay. I think I'm getting it now. For about 5 seconds.
It just takes time. It's a different way of thinking because we don't do distributive property on division.
Not
They just
normally, no.
they just barely started teaching distributive property in multiplication, so you don't need to memorize anything higher than 10.
No, yeah. Yeah.
It's like
You,
dumb.
you,
I don't
you
know
don't
why
need
they
to do
didn't teach us.
drill to kill either.
Yeah. Yeah.
So I just, yeah, when they time you for a minute, I still don't understand. I mean, my daughter did it. I mean, her
Well,
finger didn't even lift, her pencil never lift the paper. That's how
the
fast she was going.
the reason why is because they feel like if you know it automatically, you're going to be you if you know it automatically, you understand. But their way of thinking is a little bit backwards
You
because
could
you
still
need
make mistakes even though you know your times table, because when you're working this problem out, I mean, you're doing those facts to see how fast you can do it, but when you're working out that problem, you're not doing this problem really fast.
right,
Unless
but they're
unless you're looking for automaticity and that automatic you'll know in your brain. But then when they go and turn around and do those um
bless you.
Thank you.
oh, what am I saying? When you're not doing just your simple multiplication and you're taking this big number and trying to get pardon me,
Bless you.
you know, 3 digits, you know,
Yeah.
there's no point in doing speed drills at that point. I mean, you
Right, but
take.
they thought that it would help.
I don't think it does. All right.
1, 2, 3, 4, 5. Is that right? Yep. 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2. I don't remember how she did it. What is the starting point? Hello?
Starting point is figuring out how many digits you got.
Yeah, what is it?
1.
3 minus 2 is equal to 1. All right. So our quotient's going to be here. We're going to put our we're going to put our dividend here. 5, 9, 2. Okay. So
Okay.
what did she do? She separated this first into 3 locations, right? Is that even right? I don't know how she did it again. I have to watch it again. It made sense when she did it. And then I was like, oh yeah, that made sense. And I did it a few times, like, oh yeah, that makes sense. And now I was like, I don't remember how she did it. So we took the 5. No. Yeah, so there's 1 here. Right? Alyssa?
Sorry, my daughter's asking me questions. So,
Oh, okay,
um,
sorry. Okay, no.
uh,
So I think that's what 1 is. So that's 1 because we have 1. And
I
then
would I'd have to watch her video because I've watched it twice.
yeah, it made
And
sense when she did it, and then I did
yes,
it, and then now I forgot. This is why I don't.
but she did that. Those blocks. She did that when you had one single digit, and
Oh, is
then
that
she
what it
went.
was?
Yes, and then she went
Oh,
to the rods and the
yeah, the rods and
the
yeah.
beads. She went to that, but and it made perfect sense when you're doing it with one digit. because I mean, actually, I even liked him better than these little blocks. The only thing
Yes.
that I would have done with her beads is, some of her rods where you have a rod of 10, I would have cut it in half so that I always
Mm.
have a 5.
Yeah, yeah, yeah. Yeah, that's an Abacus-Why.
Yeah, and I don't know if the beads would have, fell out or anything if I did that, but
Yeah.
that would have been cool to just take, because then you don't have to count out 10 beads
Yeah,
for the
yeah,
for the
yeah,
ones, you know.
yeah.
So,
Uh, I'll have to. I'll try to figure out how she did it with the blocks again. But
but it was with a
um,
single digit, and what was cool with her video, because it was like 4,000 something. She
yeah,
showed you, or 400. She showed you the 4, and then she showed how she took one of those and she converted into 10 rods for the
yeah,
hundreds, and
yeah,
then she converted the 10 to 10 beads. And she did that as you were subtracting, and it was cool.
yeah,
Um, and so that when she did that, I thought of how, but see, yours in here is also having well, it depends on what formula you're doing on the abacus.
what do you mean?
Well, minus the 10 plus whatever, plus,
Oh yeah, yeah.
because
The tens and the
that
fives.
yeah, that's kind of what she's doing. She's trading, and
Oh yeah, yeah, yeah. She's grouping and regrouping. Yeah.
she's grouping and grouping, and we are grouping and grouping on abacus too,
Yes, we
right?
do. Yes.
Okay, and that's why I thought of you when I saw that video. I'm like, yeah, Lynette's doing the same thing on the
Yeah.
on the abacus. It's just that Elisa can't keep track of where her fingers are, so she's going but she's doing the division. But now that you've done this and you told me a little bit more of the importance of the leading zero, and where, so I think I can follow you more, because where you're 1, 2, 3, and then you have 2, so then um you
What's
have,
your starting point?
yeah, my starting point is 1. Okay,
Yep.
so I go
So I'm
over
gonna be
to,
here.
yep, you're gonna be right there. I need to take out my 22. Hold on. From the other problem. Okay, so then you have 5, and then you have 9, and then you have 2. So, okay, so now the first thing you're asking yourself is 3 times what equal is to 5.
Yeah. So we do the first one, which is the 3. 3
Yep.
times what is equal to 5? Again, 5 is a single digit, so we make sure it's a 0, 5.
Mm-hmm.
This is what's going to push your quotient to here.
No, okay, it pushes it into the tens place because of the 0.
Yes.
Okay, and that's where you're going to put your
Answer
answer, which is 1.
1. So put your 1 there.
Put my 1 there, and then I subtract. Oh, do I?
0, 3 is equal to what?
2,
Yes, 2,
0.
right? Minus
Yep.
the 5 plus the 2. Don't forget to bring down the 9.
Mm-hmm.
What are we going to do? Because we do it to the 3, we got to do it again to the 7. So 7 times what? 7 times 1 is equal to 0, 7.
Hmm.
Because we
Okay.
only work with 2 columns at any given time.
Okay, so what happens to that 2 then?
It stays. So let's do it. 22, right?
So you subtracted the 20, not the 22. You subtracted.
No, I subtracted the 2. I subtracted the 7.
Oh.
The 2 comes down. This becomes 2. And then your next one comes down to 2.
Okay.
So now I take away the 7. My new answer is 2, 2, 2. So what we're doing is we're doing partial division.
Oh. I see. And
So
now
we do
you
it again.
do it again. So then you go.
What times 3 is equal to 2? Can that work? No.
No.
You got to do 22.
7.
2. Yeah. 7 equals 21.
21.
So you 7 here, take away 20, take away 1. What?
Okay.
7? Is that right? Did I do that wrong? 7 times 7 is. Oh. Oh. This is wrong. Because now, did I write it wrong? It's supposed to be. Okay. So 7 times, so that's 21. So we're get left with 1 and then 2.
Uh-huh.
So what happens?
Doctor
You
doesn't
can't.
see me back for
7 times 7 is 49. Is that even right? That's not right. Can't do 49. That's not right. Oh, you know, no. So this is where we call over quotient. So you actually have to take one from the answer, go back, and then add the 42. Oh yeah. Okay. This is a little bit more advanced, but it's fine. I mean, we're stuck here. So what we're gonna do is, yeah. So what we do, instead of doing 7, you do 6. So this would be good for Tammy.
Yeah, well, my husband came in, so I got distracted. So I will have to work on this one again later.
Yeah, this one would be good for you,
Yeah,
Tammy.
I was thinking 7 was going to be too much anyway.
Did you talk to her?
Yeah,
talk
but
to
see,
her.
the thing is why is it too much? The reason why it's too much is because, yes, the reason why it's too much is because, so what happens? What did we do? Okay. So what did we do? We did 2, 1, no, 2, 2, 2, take away 200, right? And
Yeah,
and so we took away, 1, we have 12 left. Now, what
right.
happens is we took out too much. So instead of doing 7 times table, maybe we do 6. So we would distribute a property. 6 times 3 is 37 times 6. So the first thing we do is 18.
Yeah,
1 is 18, right? And then we do 42.
42.
So if we did, so that's where if you think about it, instead of doing 210, we add back the 30. So instead of doing 210, we want to do 180.
Okay.
Why? Because we got to add it back. Because if you notice, 210 and 180 is 30. So you got to add it back to here. So we take away, so instead of doing 7, we do 6. So you add back the 3,
Okay.
and then it just works itself out. 42.
I see that.
It's a, yeah. So I think what I need to do is I need to go through this long way, and then you're going to start seeing it. You do this a couple more times, and then you're going to start seeing it. And then all you know is just to add back. So like for me, I know I'm just going to add back the 30 back.
Okay. Hey, Lynette, you got about 10.
Oh yeah, thank you. So yeah, I've been working on the division questions as well as trying to make sure that it made sense. So
Yeah.
there's gonna so
I got you on the first problem, but there was too many distractions, and I totally lost you on the retrieving back.
yeah.
'Cause
So
yeah.
yeah, this is a take one step back to regroup is what this is. I gotta redo my
I
questions.
understand it. I'm starting to understand it even more than I did before.
Yeah, yeah,
I'm where you once were. Okay.
yeah,
I am where you
yeah.
once were. Sorry, Tammy. So I'm like,
It's not a problem.
Yeah, it does take time to understand what you're trying to do, but this is where you get number fluency and number flexibility.
Yeah,
This
I
is the
agree.
ultimate number fluency and number flexibility is when you understand why you go back and it just kind it Tammy, you're gonna really love division. It's just so good.
I think so. I think you're right.
It's just you're yeah.
So where did you get the 49?
I got the 49 because
What's the
it's
whole
a
number again?
7 times 7. So the problem is there's not enough to take away 7. There's not enough to take away 49. So instead of
Oh.
doing 7 times 7, I have to do 7 times 6. Remember we started off with 3 times 7 is equal to 21.
Yeah,
Hmm.
I got that.
That's the overestimation. We overestimated. So we got to take one step back and make it a 6 instead of a 7.
Well, let's put it this way: it's not as scary as it once was.
It's not you're not this is why this is advanced. You're not here. This is why
I'm
this is
getting
not a good
closer.
question. Yeah, this is not a question and I was trying to filter out the questions that would make sense like I always do. I got to find the proper algorithm to give me
Yeah.
So
the proper
where's the overestimation? Where is that on the abacus?
where is it? It
Yeah.
is it's the 7. That's the overestimation.
Oh.
When you try to multiply the same digit,
Okay. So
okay, when you go ahead.
37 times that by 7. So let's do what is this? It's 21, right? And then
Yep.
49.
9.
So my answer is 259.
Oh.
But instead of doing this, I need to minus 37, right? To give me 222. I need a new piece of paper. So, and that's the flexibility that I'm looking at. That's the flexibility that happens when you go to division. Division is the most difficult to understand because we don't do division nicely regular
We probably
school.
don't do it enough. Okay, can you start from the beginning, from the top?
Do we want it with the same question or a different question?
No, let's have the
I
same
think a
question.
different question.
Different question. Okay.
Yeah.
All right.
Because
I
I
was
don't,
just well.
because I don't want it to, I don't want that overestimation to confuse you.
Well, but I need to understand what that overestimation is. Otherwise, I'm
Yes, but
still gonna be.
you can't get there until you understand division. There's steps, right? You got to do one step after the other. You just realized what quotient was and where it is on the abacus. You can't be jumping 4 steps ahead if you don't know the first 2 steps.
No, but I can visually watch.
Yes, you have. And that's where we're at. I'm not dogging you. I'm just saying I don't want to.
I'm sure I've done this before. Um, but
Yes, we
I
have.
but I'm talking about even way back before I even. But now I'm like, oh, okay. So that overestimation is that we're doing something too much.
Yeah.
We're making the because you're dividing out that did too much or multiplied out too much. Is that basically what
Yes.
you're saying?
So what we're doing is we did it distributive, right?
Right.
592, right? Because we're here. So
Mm-hmm.
when we're looking at it, we know it's 1. 37 times 1 is equal to 37. We know we could do 30 and we could do 7,
Yeah.
right? But the way we do it in Abacus is we go 3 times 1 is equal to 0, 3. That goes here,
Mm-hmm.
right?
Mm-hmm.
So this becomes 2 and this becomes 9. So
Mm-hmm.
we have, because whatever we do here, you got to bring that down. 7 times 1 is equal to 0, 7.
Okay. So whatever you're doing to the 3 first, you have to do the same with the 7. I got that.
Yeah.
Yeah. Okay.
Okay, so if we added these together, that's what this is. So what we did is we did 39 minus 37. That's what we did. So our answer becomes 2 and then 2.
Yeah.
Got to bring this down. So I bring it down, becomes 2.
Mm-hmm.
Okay, so let's redo.
Now you go back to the 3 and 3 times. Oh,
Okay,
yeah. Okay, because that was the 1. Oh, okay. So you just made my dividend smaller.
yes, because we're subtracting. That's what we did here, right?
So every time you're subtracting, you're making the dividend smaller. And so
Yes.
that's why you can take 37 and now well, you probably are. Yeah, you are dividing. Yeah, seeing that. Okay. So then you basically say
What did
3
we know? We know 3 times
times
7 is
7.
equal to 21.
Yes.
Mm-hmm.
3 times 7 is 21, right? So that means we need to know 7 times 7 is equal to 49. So our answer actually becomes 259.
So
If you work it
that's
out,
where I got lost. That's so set because you have to
yeah.
wait.
So this is where but we subtract already on the abacus. I'm just showing you on paper.
Okay, and that's where you
So
got the 222. Okay,
what?
go ahead.
No,
Go ahead.
222 comes from the original,
Oh, okay.
right? I rewrote it so it's a little bit cleaner. And then this will be my last one.
Yep.
Okay. So what do we know? We know 3 times what is equal to 2. That doesn't work.
Not at all.
So that's why you need to do double digit,
Mhm.
right? We know what? We know 3 times 7 is equal to 21.
Correct.
So I'm going to do it. I'm going to take away 1, take away 1. But now when I look, I see 7 times 7 is equal to 49. I don't have any room to take away 49.
Honestly, the best you can do is 7 times 3.
7 times 3. Right. From here, 7 times 3, it looks like it. But when you bring in the second digit, you know you've done too much. So you got to take away 1 from here. That becomes 6. So instead of doing 7 times 7, it should be 7 times 6 is equal to 42.
Okay.
But because you take away here, you got to add back 30.
Yeah.
Oh, you took away 7 because you have 37, so now you have to add back
Yeah.
the 3. Okay.
Yeah. So this becomes out. So you got to add back. So it's actually this right here. You have to add back the 30 because you, instead of taking away 7, you want to take away 6.
You have to add back what you took. Okay. Go ahead.
That's it. That's it.
And
So
that was the
42?
problem I had understanding before. Now
Yeah. But see,
all I've got to do is practice more, but I understand now where it's all coming from.
yeah, it's just, finding a different way. Because, yeah, I have to figure out a better way to explain this part here.
So when they're doing it, because this is all through, are you gonna get the same results if you did uh, um, where they put the whole entire number in there?
Yeah, you get the same result. It's just more cumbersome because you got to go through 37 times 1, 37 times 2, 37 times 3, 37 times, and then you can figure that out.
Oh, I see. But by
Yeah.
doing it this way,
You're able to strengthen your concept of multiplication, and you strengthen your concept of your number flexibility and number fluency.
My thing was before, because when you're doing the, okay, say we got the 37, well, the 3 times 7 is 21. So you're already you're adding a 3 up there. You're taking the 21 out. So now, but you got to you've got to bring, I know what I'm trying to say, but yeah, I understand what you're doing now.
Yeah. So that was the thing. You have to add back what you took out. And this is why division is a little different. It's a little different because we don't normally divide.
Right.
So
But see,
now we're
it's
going
a
the
little more
reverse.
clearer to me now.
Yeah. So now we're going a little bit more reverse, right?
Mm-hmm.
Because and that's the things like you don't, yeah. It's a different way of it's a different way. Because in regular math, in regular school, they do 37 times 1 is equal to 37. 37 times 2. And this is front loading all this information, right?
Yes, it is.
And yeah, I was never taught this way, but I
I
see
was.
people doing, right? So
Yep.
but we don't memorize our multiplication facts of 37.
No.
So that's why this is a little bit like, it's a little bit
I would just call that I just call
overwhelming. This is not distributive property. This is
just,
memorizing your math facts.
but you have to multiply it out.
Multiplying out is this is distributive property. This is not distributive property. This is partial division.
Mm.
Because
There's your okay.
6,
Okay.
7, 8, 2, 9, 6. And then I don't know. I don't know how you tell the kids to stop. I don't know what they say. But I tell them to go through. I don't know if they go to 12.
Do they even recognize that? So what I would do is I would put a box around the 222 because each time you're subtracting, you're making the
Dividend.
dividend smaller, and that's so now you're going and dividing your 37 into 222. So,
Yeah.
but I don't know that you got to be able to know and recognize that.
Yeah, exactly. You have to recognize. So if this is the number, you're going to have to recognize that 37, you can't do 47. Sorry, you can't do 74 here. You have to do 37. But my question is, how does the kids know to go 2 digits or 3 digits?
I don't know.
So like, what would you have them do? Keep them writing it out until they get to 592? Right?
I don't know.
I don't know how they I don't know how they teach it, because my kids didn't do this. My kids do distributive property. So anyways, but that's the difference. So what I want to know is, how do you tell the kids to just look at this? Like, so they're like, how many times does 37 go into 59? That's what they'll say. And you say 1. I was like, okay, so write the 1 there. So 1 goes there. And then they're like, okay, now subtract. So you get 222. And then they have to figure out, okay, so here I already front loaded it. I already did my multiplication. I know it's 37 times 6 is equal to 222. So just put the 6 here.
Yep.
Yeah. So that's the public school way.
Oh,
That's
hold that paper up again. Go upwards.
Oops. Yeah.
Oh, there's your 1. There's your 6. Oh.
Yeah.
Okay. Okay.
But yeah, but then you still have to estimate. I think it's going to fit here. You still need to know, I don't know. You still need to know, less than 59.
Okay.
You see, for me, I can look at 37 and I look at the first 2 digits and I see 59. I already know you're not going to go anywhere above 1 because 3 times 2 is 6.
Right.
So,
Right. Right. But see, what happens is when the number gets bigger, you don't want to start over.
no,
So if you
not at
understand
all.
this concept, this will translate when the numbers get bigger and longer. So if you did 4 digits divided by 6 digits, you don't want to go back and be like, oh, I did that wrong. I got to, go back. You want to take from where you are, because what we do is we do a running total.
Okay.
So that's why it's critical to know this step. Just like when we do 1738 minus 5, no, minus 2, 3, 6, 7, 9. We'll do 9 minus 9, 4, 3. So this 9 here, I don't want to be 900 minus 900 is equal to minus 1000 plus 1. I don't want to do that.
No.
It's the same thing with this. you want to understand this fundamental concept, because once you get this concept, then it doesn't matter how big the number is. This is really minus the 9 is equal to minus the 10 plus the 1. So this is what I would tell Avram. You could say it, but really know that it's minus the 9 plus the 10.
Yeah.
You know what I mean? Like I actually wrote it out when I did my regrouping.
Oh, you did?
Yeah, in book 2, it was this one, right? When we did 3 digits,
Yeah.
it's minus 300. It's still, we're still taking away 300, but we don't want to say 300 minus 1000 is equal to 700, because that gets confusing real quick, right?
Yeah.
So it's still minus the 10, minus the 3 is equal to minus the 10 plus the 7.
Yeah.
Because you're still working with just these 2 numbers. Hi, Avram.
Yeah.
So, does that make sense? So
Yeah.
that's why I keep telling Tammy, once you understand this, then it doesn't matter how big the numbers are.
And I'm getting closer to it. I
Yeah,
really am.
it does take time, because it's a different way of thinking, and we don't do distributive property in division. We barely do distributive property on multiplication. We do definitely distributive property in algebra.
Yes.
Oh, okay.
But they never translate it to multiplication, which is very interesting.
Yeah.
So I think it's a new concept for the young kids to start understanding distributive property. But when we did it with an abacus, all the abacus kids know it because it's just part of the abacus.
Yeah, it's just part of it.
Yeah. So, and that's why it was hard for me to explain, because I didn't know that's what we were doing. I just knew that this is what we're doing. So that's why I'm trying to find a different way of explaining division, because everybody else because nobody else can explain it the way I do. Like so somebody came into my live and they were like, we're learning how to do the Kramer, but I don't know why we put the numbers where we put it. And I go, I don't know why they do it the Kramer way. I don't know why they do it that way, but I'll show you how I do it. Kramer is an abacus that's more stiff, and it's for blind people.
Oh, okay. Yeah.
And so she's taking classes to learn to teach other people, but she likes my stuff better. Because when I explain it, I explain why. And so that's the biggest thing for me, is making sure I explain why are we doing it and how it works. So that's why it's critical for me to continue to explain it's called, I don't know if they call it over quotient, because I see other people do it and they just went straight to the number and they never overestimated.
Well, in the Braille, they don't spell the words the same way either.
What do you mean?
Some of the words are not spelled the way we spell them in English. I can't give you an example, but I know some of the words are not spelled the same way.
What are we talking about?
We used to talk about the Kramer abacus.
Oh yeah, right. Oh, and Braille. Yeah.
Yeah. I used to be able to give you an example, but I can't now.
No, I wouldn't.
Too many years.
Yeah, no. I heard that Braille math is very different, but they were using the Kramer abacus with the abacus method. Like I've watched their videos, but I don't understand. They never give a rhyme or reason on how they know their place values on the abacus. Yeah, that was the one thing I couldn't really quite grasp. And it was the same thing with the other people too. So I like this method that I have, that when I was taught, I think it's a good, it's just needed to be tweaked a little bit more. So I gotta go back and I gotta figure out all these questions. I guess I'll have to pick and choose these questions because I'm gonna start doing the division
Cool.
books. Yeah.
That's
There's
good.
division's gonna be, there's gonna be the single one, just like I do multiplication, and then there'll be the double digit, and that's gonna be bigger.
Yeah.
That's actually gonna be more heavier because it's a lot more, there's a lot of information on that one.
There's
And
a
then
lot
I
more
think,
work behind it.
I didn't, it was really bringing me down a little bit, and it was just one of those things, like once I get this out, once I get this done, then that's the whole curriculum, which is crazy, which is really crazy, but it is what it is.
But then you got to make advanced models.
Yeah, exactly. Yeah, I got to keep going and and then show the different things, but once I get this down, then it'll make more it's a lot easier to break it down. I don't know if you know Heather, but Heather came in and she was really upset about multiplication
Why?
because she doesn't realize that she's not strong in her chaining equation, and she's on page 79 in my workbook. She's on page 79 in my multiplication workbook, and she's like ripping her hair out because she's like, I can't believe this, you're making it so hard for me. And I'm like, I'm honored to know that as long as she's been doing abacus, that it's still challenging for her, that I could still provide a little bit of challenge and get her to be more. Yeah. So she's doing this one right here. No, that one. And she's like, I don't get it. I'm like, what? So, but other than that,
everybody has their stumbling blocks, but okay.
Yeah.
Let's have you come here. We'll talk her through it.
Yeah, I've been trying to get her to come here. Tell her that the office hours, it'll be good to get a different take. But she's been doing abacus for about 10 years, and she's taught her kids, but I don't know if she did multiplication with her kids. So
you did division with your kids too?
My kids, yeah, my kids know it.
Oh wow.
Yeah, I showed you what it looked like. And then they also did decimals.
Wow.
Decimals are easy.
Just
a point putting there with the numbers.
Yeah, I think the biggest thing is making sure when you divide or multiply decimals is dividing decimals, you have to multiply it out. I forgot that. So anyways, so if there's no other questions, Elisa, are you okay?
Yeah, I'm glad I sent you that video.
Yeah, it was a good video. It was a really good video. I really enjoy watching other people do things. And it's interesting to see how her take is as well. So I'm going to watch it again. Try to get that division stuff.
So if you're basically saying that Singapore math and most of the other math is Eurocentric,
yeah,
then what is abacus called?
Abacus is not Eurocentric. Tammy?
It's not Eurocentric.
So then what is abacus if it's not Eurocentric?
It's just math, really. It doesn't have so it came from Mesopotamia. So and then it just kind of morphed, and it was more, I guess, Eastern, because Chinese used it and then the Japanese used it. So it's more Asian.
Okay, more Asian. Okay.
I guess it's more Asian. I guess you would say it's more Asian.
Yeah, I would say it's more Asian, yeah.
Okay, and Eurocentric math European math is where they're using define Eurocentric math.
Western math. So whatever you see in public schools, whatever you see, like all the math curriculums that's in America, all of those is Eurocentric math.
Okay.
So anytime that you're dealing with like even the strategies, like doubles, near doubles, I don't know what else there is, number lines, all that stuff, that's all like Eurocentric math.
And
Mhm.
the rest of the world does what?
Well, they're divided, but most of the world does Eurocentric math now.
Oh, most of the world does.
Yeah. Yeah.
I
There's
see.
Yeah.
there's like pockets of people who do abacus math, but it's not a either or. It's a marrying of the two, right?
Yeah.
So like
We
in
separated, and then we're trying to come back.
yeah, right. And so it's not a yeah, so a lot of the thinking now is we need to have concrete evidence. We need to have concrete stuff. That's why you have all these building blocks when we already had it with the abacus. See the difference?
Mm-hmm.
So this is Eurocentric because they're like, okay, well, we got to do this and we got to go back to our roots. Well, they're
It's
just
kind
going
of
back to
like
abacus.
Occidental and Oriental thinking.
Yeah, yeah. I wouldn't say Oriental though.
I would say
Okay,
that,
okay,
you
okay.
know,
Well, I'm talking. Well, okay.
Eastern
Occ-
thinking.
Yeah, Eastern thinking, where
Eastern.
basically where
Yeah.
you're not.
I,
You know
I
how
don't
you have
mind it. I don't mind it because I grew up with that word, but there's a lot of people that will cancel using
Yeah,
that
yeah,
word.
yeah. Okay.
So
So, well, then what's the word? Okay, so there's
I'd say Eastern,
Eastern
Eastern
Eastern,
and
Asian.
because
and
Western
Western thing.
Western thinking is more abstract, correct?
Yes.
More
Yeah.
with the details. Is that what it is?
Not
No,
details.
they're more
More trying to get the kids to jump ahead when they're not ready.
okay.
So
And then Eastern thinking is what?
I
Taking
don't know, smaller steps and just kind
smaller
of
steps.
having
Okay.
having what you got and then moving it.
Okay.
So, but like I don't know Eastern thinking. I grew up in Canada. So
Oh.
I grew up with American math or Eurocentric math. We had to memorize everything.
Oh. Okay.
So
Canada.
I can't say what's the difference, but I just know what the difference is between abacus and regular math.
Oh wow.
Yeah.
Cool.
Yeah.
Yeah.
So
All right.
yeah, like I
Gotta
don't know
go.
what they teach in school. Yeah.
I gotta go.
Yep.
Okay.
Yep.
Likewise, but thank you again, everybody, for
Yep.
joining.
All right. Bye.
Bye.